Hello and welcome to another episode of Mr. Boskin Does Some Math. Today we are doing Illustrative Math, Grade 8, Unit 8, Lesson 4. So now we're going to start working more with square roots on a number line. Our warm-up question is a what do you notice, what do you wonder? We have a circle. The center of the circle is at the origin, 0, 0. We know one point on this circle is the point 1, 1. So what do we know about this circle? Well, looking at it, we know the radius of the circle is greater than 1, less than 2. It looks like it's approximately 1.4. However, we can see that line inside here, so it has to be a little bit greater than 1.4. What do I wonder? What is the exact radius of this circle? We can find out the exact radius of this circle, and doing that is what we're going to investigate today. So our first activity here is called squaring lines. Estimate the length of the line segment to the nearest tenth of a unit. Each grid square is 1 square unit. So if we want to know how long this is, approximately, we could measure it. We could use tracing paper and trace this length and then lay it out exactly on here. We know it has to be greater than 3. Because this length is 3 and this diagonal is clearly longer than that. So it is longer than 3 units. Use a ruler, trace it. There are a couple different ways to find out an approximate length, but what we are really worried about here is how do we find the exact length of this line segment? Well, to do that, we are going to start doing something that we've been doing, which is finding the area of a square and using the area of the square to find the side length of the square. But where's the square? All I see here is a line. We are going to have to create our own square here. So in order to create a square here, we have to think about where the other lines are going to be. A square is 4 right angles, 4 90-degree angles, and 4 side lengths that are all congruent to each other. All the side lengths have to be the same. We don't know exactly how long this is. We could use a protractor and try and find angles, but the easiest way to do this and the most accurate way to do this is not to do that. It's to look at this line here and our grid. This line, because it connects vertices on our grid, we can tell that it goes over 1 and down 3. So this line here would have a slope of -3. If this one has a slope of -3, the other side of our square is going to have a slope of -3. Well, where would that be? It's going to be somewhere around here. But to find out exactly, if we want a right angle, if this line goes down 3 over 1, our perpendicular line is going to have to go up 1 over 3. Up 1 over 3. Now, this line has to have the same slope as that, which is down 3 over 1. Easy way to make sure both of our other lines are where they belong. And now we have a square. Each of these sides are congruent to each other. So now we just need to find out the area of this square. How are we going to do that? The same way we've been doing it, by enclosing it. Finding the area of the outer square, which is 1, 2, 3, 4 units. 4 units squared is 16 square units. How big are each of these little side triangles around it? They are 1 unit by 3 units. 1 times 3 is 3. Over 2 is 1.5. 1.5 times 4 is 6. 16 units subtract 6 units is 10 units, which means the area of this square is 10 square units, which means the side length of this, how do we find the side length of a square if we know its area? We take the square root of it. So the square root of 10 is the side length of this square. Approximately, that's a little more than 3, because we already said this has to be longer than 3. The square root of 9 is 3. The square root of 10 is going to be more than 3. Find the exact length of the segment. Remember, to be exact, this is our chance to be a little bit lazy. The exact length is the square root of 10. Our next question here, Diego said he thinks the square root of 3 is approximately 2.5. Use the square to explain why 2.5 is not a very good approximation for the square root of 3. So, for 2.5 to be the square root of 3, the side length of a square times the side length of the square would give us the area. The area of this square is more than 4. 1, 2, 3, 4. We have 4 full units in here. If this is 2.5, we have this full unit, this full unit, this full unit, this one. Those are both half a unit, so that's another one. Those are both half a unit. So we have 1, 2, 3, 4, 5, 6. And this one here, which would be 1/4. So the area of this square is 6 1/4. Which means the side length is the square root of 6 1/4. That is not close to 3. That is not close to the square root of 3. So, what we want to find instead is a better approximation for the square root of 3. Which would mean we want a square that has an area of 3 units. Well, how do we find a square with an area of 3 units? Well, we can't do it using these square because, like, that space is 3 units. That doesn't really help. How are we going to do that? Could we do a diagonal square? What if we did a square like that? Well, this square, this is half, this is half, this is half, this is half. This has an area of 2, so this length is the square root of 2. We could do this square. What's the area of this square? Well, we could enclose it. This square, we can tell it's a square because we went down 1 over 2, and then the opposite of that going up the other side, up 2 over 1, to create right angles. Now, the area of this outer square is 3 times 3, which is 9. The area of each of these pieces here is 1, 2 by 1, 2 units. 2 times 1 is 2, over 2 is 1. 1, 2, 3, 4 of those. So the side length of that is the square root of 5. So that is a closer approximation, but still not quite right. So 3, unfortunately, is a trickier one, that there is no nice, easy way to make a line that is the square root of 3. We just need to create a square which has an area of approximately 3 units. I'm going to say something like that because this is 1 complete unit. That's a half a unit, and that's a half a unit. In here and in here. So that's 2 units. A little more here, a little more here, and a bunch more here. That's approximately 1 unit. So if that has an area of approximately 3 units, our side length is approximately the square root of 3. So really, any length in here that you drew where the side length is between 1.5 and 2 will give you a good approximation, because 1.5 would have a side length of the square root of 2.25, and 2 would have a side length that is the square root of 4. So if you're between 1.5 and 2, that's a good approximation. Our next question here is, use the fact that the square root of 3 is a solution to the equation x squared equals 3 to find a decimal approximation. So for this, you need to find a value that you can plug into x, that if you multiply it by itself, you will get 3. Now, when you do that, you should be getting approximately 1.73. Are you ready for more? A farmer has a grassy patch of land enclosed by a fence in the shape of a square with a side length of 4 meters. To make a suitable home for some animals, the farmer would like to carve out a smaller square to be filled with water as in the figure. So we had a 4 by 4 square. We want this smaller one to be, what would the side length of the smaller square be, so that half of the area is grass and half of the area is water. So the area of this whole plot of land is 4 by 4. 4 times 4 means that has a total area of 16, what is it, meters? Yep. 16 square meters. So if we want this blue square to be half of it, its area will be 8 square meters. 8 square meters is half of 16 square meters. So what side length do we want this to be? Well, how do we find the side length of a square? If we know its area, we take the square root of it. So we want that side length to be the square root of 8 meters. The square root of 8 is an irrational number like we've talked about, so there is no exact value. But the square root of 9 is 3, so the square root of 8 will be just a little bit under 3. Okay, this has been another episode of Mr. Boskin Does Some Math. Thank you very much for tuning in.